Today we're going to be doing a lesson on writing molecular ionic and net ionic equations. Now, molecular equations are the regular type of equations that we would normally write out a reaction as. That's what we've been doing all year. But now we're going to be looking at, now that we're into solution chemistry, when things dissolve in water, okay, they become ions. So we break apart compounds into their ions in ionic equations, and then net ionic equations show only particles that are changing in a reaction. So you're going to get some ions looking the same at the start and the end of a reaction, and some ions changing state, and those are the ones that we're going to write out in our net ionic equations. So we're going to go through each type looking at a couple of examples, and then there's some practice questions for you guys to do before our next class. So looking here, molecular equations, these are all the normal types of equations. We write everything out in full form. So full form, and we include their state symbols everywhere. So full form just means sort of normal. We're not breaking it into ions or doing anything special with it. So in this example, we've got copper 2 sulfate and sodium hydroxide reacting to make sodium sulfate and copper 2 hydroxide. You'll notice we have our state symbols written in aqueous, 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 and then copper sulfate, or copper hydroxide, pardon me, is a solid. So it's not going to be dissolving in water. It will form a precipitate in this reaction. So if we do another example on our own, barium nitrate. So barium always has a charge of 2+, that's where that comes from. Nitrate has a charge of 1-. So we crisscross, we write it out normally, and we need to add our state symbol to this. So looking back at our solubility rules on the back of your periodic table, you can check and see, okay, nitrates are always soluble and there's no exceptions. So we know that this is going to be aqueous. Then we're going to be reacting that with potassium sulfate. So potassium sulfate, looking at our solubility rules again, sulfates are usually aqueous. There's a few exceptions, but potassium is not one of the exceptions. It's a group 1 metal. Group 1 metals are always aqueous. So this one will also have the state symbol of AQ. Now this is a double displacement reaction, so our potassium and our barium are going to switch places. When we form our products, we're going to get potassium nitrate, KNO3, and barium sulfate. Now barium has a charge of 2+, sulfate also has a charge of 2+, so when we crisscross, it would give us 2 and 2, but we reduce always to lowest terms with ionic compounds, so barium sulfate will just be BaSO4. Next thing we need to do is our state symbols for our products here. So potassium nitrate, remember nitrates are all aqueous, no exceptions. So it's going to be aqueous. And then barium sulfate. Sulfate is usually aqueous, but barium is one of the exceptions. So it's going to be insoluble. So we give it the state symbol solid. So this is going to be a precipitate for this reaction. Last thing we need to do is we need to balance this reaction. So molecular equations should always be balanced as well. Here we have 1 barium, 2 nitrates, only 1 nitrate. So we added 2 in front of there. That gives us 2 potassiums, 1 sulfate, and 1 sulfate. So this is just our regular equation like we've been doing all year so far, and that's our molecular equation. So moving on to the next type of ionic equations. Now the special thing about ionic equations, any compounds that are dissolved in water, okay, dissolved in water will have the state symbol aqueous, are broken into their ions. Okay, so we write them as ions. Now an ion is assumed to be aqueous, so you don't actually have to write like the state symbol AQ for every ion. You can assume that if it's an ion, so an ion means it's charged. Just a quick reminder there. Charged. We can assume that it's aqueous. So we know it's aqueous, we don't have to write that out every time. So an example here, if we look at sodium sulfate, when we break that apart into ions, when it dissolves in water, we crisscross backwards. We'll get our Na plus and our SO4 2 minus, but we also have to make sure that it's still balanced. So here we have 2 NAs, so we need to make sure we have 2 Na pluses in the ion form as well to make sure our equation is still balanced. So again, a really important step here that people miss a lot of the time is to still make sure that your ionic equation is balanced. Looking at our first example here, we had copper sulfate and sodium hydroxide reacting to make sodium sulfate and copper 2 hydroxide. When we break that apart, anything that was aqueous, so here copper sulfate was aqueous, so we broke it into Ca2 plus and SO4 2 minus. Our 2 NaOH was also aqueous, so we break it apart into Na plus and OH minus. But remember that this 2, okay, needs to go for everything that follows it. So we have to remember to keep it balanced and have 2 in front of each of our types of ions. Then our products, we have sodium sulfate is aqueous as well, so we are going to break that one apart too. We've got 2 Na pluses, that's from the 2 that's there, saying that there's 2 sodium ions, so 2 sodium ions and 1 sulfate ion. And then our last product here, copper 2 hydroxide, this one's a solid, so we write it out again as copper hydroxide 2, and we include the solid as the state symbol on that. We do not break that one apart because it's not aqueous. Only aqueous things get broken down into ions during this step. So looking at our other example of barium nitrate and potassium sulfate, let's break that one into an ionic equation as well for extra practice. So barium nitrate was aqueous, so we're going to break it apart into its ions. So we're going to get barium, which is Ba2 plus, nitrate, which is NO3 minus. Now the charge on nitrate is 1 minus. You can always check your charges of polyatomic ions on the back of your periodic table to see what they're supposed to be. But again, we want to make sure that it's still balanced. So here we have 2 nitrate ions, so we have to make sure that we put a 2 in front of our nitrate ions down here as well. Plus our other reactant is sodium hydroxide. Oh, no, that's the wrong equation, sorry. Potassium sulfate, so barium nitrate and potassium sulfate. Crisscross backwards to get our charges, so potassium is 1 plus, and sulfate, SO4, 2 minus. Again, you can check your periodic table on the back to see what charges of polyatomic ions are if you forget. And we want to make sure it's balanced. So here we have 1 SO4 ion, but we have 2 potassiums. So we'll have to put a 2 in front of the K pluses. And that's all of our reactants. Moving on to our products, we have 2 KNO3 aqueous. So our potassium nitrate is going to break apart into ions as well. In this case, K plus and NO3 minus. So remember, potassium is a group 1 metal. It has a charge of 1 plus. Nitrate is a polyatomic ion with a charge of 1 minus. But still making sure it's balanced, we have 2 of each of these. So we need to keep that 2 in front of each of our ions as well. The last piece, our barium sulfate, is the precipitate. It's a solid, so it is not going to be broken apart because it's not aqueous. So we'll write that one as usual as BaSO4, barium sulfate, solid. And that would be our ionic equation. So again, ionic equations, molecular equations broken apart into ions, but we still have to make sure it's balanced. So you're going to have a barium and a barium, 2 nitrates, 2 nitrates, 2 potassium ions, 2 potassium ions, 1 sulfate, 1 sulfate. Now the last type are called net ionic equations. Net ionic equations, the special thing here is that all spectator ions from the ionic equation are removed. Now a spectator ion, the definition is there, is an ion that doesn't change at all. So it appears the same on both sides of the equation. If we look at this copper sulfate example and sodium hydroxide, you'll see that sodium here looks exactly the same as the sodium here. So when it's the same on both sides, we call that a spectator ion. And what we do in this type of equation is we remove that. So I'm going to move this down a little bit to the last bit. So here's our example for, this is just rewritten out, lower down the equation, the ionic equation for our example, copper sulfate and sodium hydroxide, making sodium sulfate and copper hydroxide solid. So we're going to cross out everything that looks exactly the same on both sides. So here, copper, here is an ion, but on this side of the arrow, it's in a compound. So it's changing, it looks different. So we're going to leave that one as it is. Sulfate, SO4 2-, here written as an ion, here also written as an ion, and see how those look exactly the same. So that would be a spectator ion, and we're going to remove those. Then we've got 2Na+, here 2Na+, looks exactly the same on both sides of the arrow, also a spectator ion, so we'll remove that. And then 2OH-, here written as an ion, but on this side it's part of a compound, so it's changing on either side of the arrow, so we leave that one as is. Once we remove the spectator ions, we can rewrite out only the things that are changing. In this case, we've got copper as an ion and hydroxide as an ion, forming copper 2 hydroxide as a solid. Now, this says aqueous. You can get rid of that. It should say solid. That's your precipitate. So going back to our other example one last time, here is our ionic equation for that example. Barium, Ba2+, is an ion on this side of the arrow. We find barium on the other side of the arrow. This time it's in a compound. It looks different, so we're not going to get rid of that one. 2 nitrate ions, here written as ions, on this side of the arrow also written as ions. They look exactly the same, so we're going to be crossing that one out. It's going to be a spectator ion. We've got 2K+, 2K+ looks exactly the same on both sides of the arrow, so we're going to remove that, also a spectator ion. And then sulfate, SO4 2-, an ion on this side, but on this side it's in a compound, so we're not going to get rid of that one because it's changing. Now for our net ionic equation, we'll rewrite out our ionic equation with the spectator ions removed. So in this example, we'll have barium as an ion, so Ba2+, plus sulfate, SO4 2-, so I'm taking out those two and only writing the barium and the sulfate. My arrow represents the change or the chemical reaction that's happening. And I'm removing the spectator ions again, so I'm not going to write those out, but I will write out my precipitate of barium sulfate as a solid. And finally, again, as long as your ionic equation was balanced correctly, then your net ionic equation should be fine, but double check that it is balanced always. So here, 1 barium, 1 barium, 1 sulfate, 1 sulfate, all good. So it's balanced. So just to recap, molecular equations, exactly the same, we've always written them. Ionic equations, we break anything that has the state symbol aqueous into ions. Net ionic equations, we remove any spectator ions, so that's anything that looks exactly the same on both sides of the arrow, and we rewrite the equation with only the things that are changing. Your homework, or practice, is on the back couple pages. I'll post the answers as well in case anyone wants to check their work. You will need to use your periodic table solubility rules to answer some of these questions, and then there's some practice questions. Here are the steps for exactly how to write out all of the different types of equations, so your molecular, ionic, and net ionic equations for the practice questions on the next page.